Greetings, detectives. Mrs. McKay here, and we're ready to start on lesson 6, case 6, systems of equations, clue 6.2. And that clue is I can solve a system of equations. So go ahead and write equations. And this time we're going to learn a new way by substitution. We've already talked about graphing, where you can graph each line and see where the two lines intersect. Now we're going to find a way that we can do this algebraically without having to do any graphing. So again, a reminder, systems of equations are two or more equations in a system. So, and what we're doing is we're looking to see if those equations have a common point, a common x and y value. And substitution is just what it sounds like. And we have used substitution all of the time. If I say, what's 2x plus 3 when x is 3, then when x equals 3, then all we're doing is we're taking the 3, we're plugging it in for x, and we're solving. 2 times 3 is 6. 6 plus 3 equals 9, right? So that's all substitution is. And we'll find that substitution works best when we have a variable that's isolated. So you want to think about looking for a variable that's isolated, because we're always going to have to get that variable by itself. So if it's already by itself, or if it's easily isolated, then that's what we're going to be looking for when it comes to substitution. All right, so let's do a little substitution right now. Here I have a system of equations, x equals 4y and 4x minus y equals 75. And when we write a system of equations, we usually put a big curly bracket next to that to show that that's a system. And what we're trying to do is we're trying to find the point, the x and the y value that is common with both of those, that will be a true statement in both of those. So the way that we use substitution is we say, here I have x equals 4y. Well, there I have an isolated variable. So could I not say, if x equals 4y, then shouldn't that 4y be able to go in place of that x right there? Because really what we want to do is we just want to be able to solve for one variable at a time. So I'm going to take my 4y that x is equal to, and in my second equation where it says 4x minus y equals 75, wherever there's an x, I'm going to replace it with 4y. So I'm going to write 4 times x, but now I know that x is 4y, 4 times 4y, and then I keep writing my equation minus y equals 75. Now I just have to simplify and then solve for y. 4 times y is 16y minus y equals 75. 16y minus y is 15y. Remember that we're just combining like terms because they're on the same side of the equal sign. 15y equals 75. Now I just solve for y by dividing by 15, and I get y equals 5. So now I know that the y value of my common point is 5. Well, now that I know what y is, I should be able to figure out what x is in either one of these. And if I've done it right, it should be the same. So I'm going to start with my easy equation, x equals 4y, and instead of y, I'm going to replace it with this 5. So in place of y, I write x equals 4 times 5, and I get x equals 20. And now I know what my x value is, 20. Now I can double check this, and I always want to double check this by putting in 20 for x and 5 for y in my second equation to see if it comes out to be true. 4 times 20 is 80. 80 minus 5, which is the y. 80 minus 5 is 75. Voila. It's correct. So my solution is 25. Now, what I'd like you to do is I'd like you to look at this next equation, this next system. I'll highlight it here in red, and see if you can identify a variable that we could isolate, because here in this one, the variable was already isolated for us, but now we want to make sure that we can get a variable by itself. And I hope you notice that this right here, this y, is probably the easiest to isolate. So go ahead and isolate those two. Isolate that y. rewrite this equation, and then we'll see what we can do for substitution. Okay, so hopefully what you did was you got that negative, you subtracted negative 4x and you ended up with y equals negative 4x plus 12. Now we have our y isolated and we know what y is. So we can take whatever the value of y is, which happens to be negative 4x plus 12, and replace it with the y value in our second equation. So I'm going to take this negative 4x plus 12 and I'm going to put it in place of that y in this second equation, negative 2x minus 3y. So I'm going to rewrite that. Negative 2x minus 3y. So I'm going to replace y with negative 4x plus 12. And that's all equal to 14. Now you go ahead and solve for x and see if you can figure out what x is. Okay, so I went ahead and did the work over here on the side, and you can see that I had negative 2x plus negative 3 times the quantity of negative 4x plus 12 equals 14. I used the distributive property, and I want you to notice that I said this minus 3 was plus a negative 3, so that I multiplied my negative 3 times everything inside the parentheses. I ended up with negative 2x plus 12x, because negative 3 times negative 4x is positive 12x. Negative 3 times 12 is negative 36 equals 14. Combined like terms, negative 2x plus 12x is 10x. Minus 36 equals 14. Added 36 to both sides. 10x equals 50. Divide by 10. X equals 5. So my x value for my two equations is going to be 5. Now I just need to figure out what the y value is. And the way that I do that is I take the value of x and I plug it into one of the equations. I'm going to use this one because it's the easiest, it looks to me, to solve. So you go ahead and plug in 5 for x and see what you can come up with. All right, and now I did my work over here. I put 4 times 5 plus y equals 12. 4 times 5 is 20 plus y, subtracted 20 from both sides. Y equals negative 8. So my solution to this system of equations is x is 5, y is negative 8. That's the point where the two lines cross. Now I can double check and make sure. I've already done it for 4x plus y, but I haven't really made sure that it works for my second one. It should if I did all my math correct, but let's try it out and just do it real quickly in our head. I put 5 in for x, so I get negative 2 times 5 is negative 10. I put negative 8 in for y, so I have negative 3 times negative 8 is positive 24. 24 minus 10 is 14, and it works. Okay, now let's take a look at this one. Y equals 2x minus 1, and then y equals 3x plus 4. This one's going to be really easy because we have two y's that are isolated. So that means if these two y's are the same, then these two must be the same. So all I have to do is write it like this. 2x minus 1 equals 3x plus 4. I basically have substituted one value of y in place of the other y. So 2x minus 1 equals 3x plus 4. Go ahead and solve that. See what you find the answer is for x. And I did my work, and I found out that x equals negative 5. Now that I know that x equals negative 5, I just have to replace one of these values of x with negative 5. So I'm going to do this one right here. 2 times negative 5 is negative 10 minus 1. Negative 10 minus 1 is negative 11. So y equals negative 11. Let's see if it works for this other one. 3 times negative 5 is negative 15. Plus 4 is negative 11. So again, this worked. All right, now what we need to do is we need to do these next two, and I'm going to have you do those on your own. Isolate a variable. It's already isolated for you. See if you can solve it. Once you're done, you may have found that you came up with 0 equals 0, which means there's no variable. So come back and we'll talk about this.